2 pieces of metal, a wooden stake, and damp soil. That is the entire build, and it costs about $20 in parts you can find at any hardware store. People have been driving these stakes into the ground for close to 200 years, and the story behind them runs through a French physicist, a Scottish clockmaker, a 19th century barley field, and a forgotten inventor who sold over 150,000 units across Europe. Today we are building it, walking through exactly where this idea came from, and by the end, you are going to know something that almost never gets said directly. Which part of this story is genuinely backed by modern laboratory science, and which part is a claim nobody has ever actually proven? Stay to the end, because the answer changes how you should use everything I am about to show you. Let us start with the build itself, because it takes about 10 minutes and the materials are simple. You need bare copper wire, 16 gauge, sold online or at hardware stores as electrical or garden wire. A 1 pound spool runs about $13 to $15 and gives you enough for several stakes with plenty left over. You also need galvanized steel wire, which is coated in zinc. A 100-foot roll of 14 gauge runs $8 to $10 at most hardware stores. Finally, grab a bundle of bamboo stakes or wooden dowels around 3 feet long, roughly $5 for a pack of 10. Total cost for everything comes to around $20 to $25, and that covers 3 complete stakes with wire left over. To assemble one, wrap about 3 feet of copper wire in a loose spiral around the lower portion of a stake. Do the same with 3 feet of the zinc-coated wire, spiraled around the same section. Both metals need to make contact with the soil once the stake goes in, but keep them from touching each other above ground. Drive the stake 6 to 12 inches into damp soil. Moisture matters here since it acts as the electrolyte in the reaction between the two metals. Pour some water around the base to get it started, and rain keeps it going from that point on with no further effort on your part. For placement, the common recommendation among people who build these is to space several stakes roughly 10 to 15 feet apart around the perimeter of a garden bed, patio, or campsite, rather than relying on a single stake to cover a wide area. For a typical backyard vegetable bed, 3 to 4 stakes positioned at the corners is the usual setup. None of this placement guidance comes from a controlled study. It is simply the pattern most commonly repeated across gardening forums and how-to videos on the subject. Now, the history, because this is genuinely one of the more interesting stories in the whole world of forgotten techniques, and it deserves to be told the way it actually happened. It starts in Paris in 1747 with a physicist named Abbé Jean-Antoine Nollet, who served King Louis XV. Nollet ran a simple experiment. 2 identical pots of soil, same seeds, same sunlight, same water, with one difference. One pot received electrical current for 10 hours a day. According to his notes, the electrified seeds broke through the soil days before the untreated ones, but there was a second observation buried in those same notes, almost as an afterthought. He recorded that small flies gathered freely around the untreated pot, while the electrified pot sat in what he described as a zone insects avoided, hovering at the edge before turning back. He did not explain why. He simply wrote down what he claimed to see. Nearly a century later, in 1841, a Scottish clockmaker named Alexander Bain buried a copper plate and a zinc plate in wet soil behind his workshop, connected by a wire above ground. His voltmeter read about 1 volt, generated with no acid, no battery, and no chemical bath, just moisture in the soil acting as a natural conductor between 2 different metals. He called it an earth battery, and by his account, it ran his clocks for months. Almost as a footnote, he also noted that the biting flies that had always plagued his workshop seemed to disappear. The basic electrochemistry behind an earth battery is not in dispute. 2 dissimilar metals in a moist, conductive medium genuinely do generate a small, measurable voltage, the same principle behind a simple lemon battery in a middle school science demonstration. Zinc gives up electrons more readily than copper, and that electron flow through a connecting wire is real, measurable current. What was never established is whether that small current, or the metal ions slowly released into the surrounding soil, actually does anything to a flying or crawling insect several feet away. The voltage involved is a tiny fraction of what any commercial electric fence produces, and insects were never tested in any controlled way during this entire 2-century period. A landowner named Robert Foster reportedly read about Bain's work and ran a network of copper and zinc wire across his barley fields near Elgin, Scotland. According to an account published in the British Cultivator in March of 1845, pest damage on the treated fields was minimal, and workers reported that clouds of biting insects that normally descended at dusk stopped short at the field's edge. The most elaborate version of this idea came in the 1920s from a French engineer named Justin Christoflo, who built a 25-foot post wrapped in spiraling copper and zinc wire, with wires fanning out into the surrounding soil, aligned north to south. By his own account, his oat crops grew unusually tall without synthetic fertilizer, and previously diseased grapevines recovered and produced full harvests. He sold roughly 150,000 units across Europe under the banner of what became known as electroculture. By 1912, an international agricultural conference had reviewed the accumulated body of anecdotal evidence and reportedly found it compelling enough that wider adoption was seriously discussed. Then, the First World War arrived, physically destroying much of the agricultural infrastructure across Europe, electroculture installations included. When the war ended, the same factories that had produced ammunition and chemical weapons for 4 years had enormous manufacturing capacity and no market. Ammonium nitrate, the base compound in high explosives, was repurposed as nitrogen fertilizer. Organophosphate nerve agent research was reformulated into modern insecticides. The chemical industry did not simply enter agriculture after the war, it restructured it almost entirely. And cheap, scalable synthetic products from that new industry became the dominant approach to pest control and soil fertility for the rest of the century. While quieter, unpatentable techniques like a copper and zinc stake in the dirt had no company behind them to promote or sell them at scale. If you enjoy this kind of deep dive into where our forgotten tricks actually come from, subscribe to this channel and hit the bell. We dig into the history behind the method, not just the method itself, every single week. Now here's where this gets more interesting, because there is a second, completely separate technique connected to the same pair of metals, and this one is not folklore. It is documented, peer-reviewed laboratory science. Take any leftover copper wire from building your stakes and drop a loose coil of it directly into standing water. Rain barrels, bird baths, any low spot in your yard that never fully drains, any container you cannot dump and scrub every few days. In 2015, Dr. Norbert Becker at the German Mosquito Control Association published a study in the peer-reviewed journal Parasites and Vectors. His team introduced metallic copper in the form of coins, tubing, and spray coatings into containers holding mosquito larvae, the same kind of standing water where disease-carrying species breed in cities worldwide. The copper ions released into the water achieve very high larval mortality rates, and this finding has since been independently corroborated by several other published studies. The mechanism is straightforward chemistry. Copper ions are toxic to the soft-bodied larval stage of mosquitoes, and unlike synthetic pesticides, insects cannot develop genetic resistance to a metal ion the way they can to a chemical compound. The physics does not change generation to generation. A coil of copper wire sitting in a bird bath keeps working, recharged continuously by nothing more than the copper simply being present in the water. So here is the honest distinction worth ending on, because you deserve the full picture rather than just the story. The copper and water technique you just heard about is genuinely backed by controlled, peer-reviewed laboratory research, published in a credible scientific journal, independently repeated by multiple research teams. That part is real, it is cheap, and it works. The soil stake version, the copper and zinc driven into the ground to create a barrier flying and crawling insects supposedly will not cross, is a different story entirely. It rests entirely on historical anecdotes, personal notes, and unverified accounts spanning nearly 2 centuries without a single modern, controlled study confirming that mechanism actually exists. Horticultural scientists who have specifically examined this claim in recent years have found no plausible explanation for how it would work and no rigorous data supporting it. That does not necessarily mean 2 centuries of gardeners and farmers experienced nothing at all. It means nobody has proven what, if anything, was actually happening in those fields and workshops. This exact technique has seen a genuine resurgence in the last few years under the name electroculture, spreading widely through gardening social media alongside claims of dramatically boosted yields and pest-free harvest. When horticulture researchers with formal academic backgrounds have taken a closer look at those modern claims, the conclusion has consistently been the same one reached a century ago: interesting historical folklore, compelling personal testimonials, and no controlled evidence that would separate a real effect from coincidence, favorable weather, or simple observer bias. Build the stake if the history genuinely interests you and you want to see for yourself. But if you want a technique you can rely on with real evidence behind it, the copper wire in your standing water is the one backed by the lab, not just the legend. One story from the history books, one from the laboratory, and now you know exactly which is which. The next video is already up. Go watch it now.